Hello and welcome to this video on whether you should use saturated models in structural equation modeling. My name is Geiser. I'm an instructor and statistical consultant with QuantFish, and on this channel I present weekly statistics tutorials. On Tuesday I usually talk about issues related to the Mplus software, and on Thursdays I present more general issues in multivariate statistics, including structural equation modeling, multi-level analysis, and latent class analysis. If this is something that interests you, then please subscribe to this channel. Also, don't forget to hit the like button and to check out the description for additional resources, including a link to my free weekly statistics newsletter and courses and workshops that I offer. In this video, I want to address a question that frequently comes up when people use structural equation models, path models, or factor models, and that is about so-called saturated models. What is a saturated model? A saturated model is one where you use all the information in your data to estimate free parameters. So for example, a model where you have three variables, say x, m, and y, and you want to estimate a mediation model where x influences m and y, and m also influences y. So in such a model with the three variables, you saturate your data structure because you estimate all possible paths between the variables. With three variables, you have three covariances in your data, and you are estimating three paths: the path A from x to m, the path B from m to y, and the C prime path, as we call it oftentimes, from x to y. And so then you're using those three covariances to estimate those three paths, so to say, simplified in simplified terms. And so then there is no information left over in your data after you estimate the parameters, and then we say the model is saturated, or we also say the model is just identified, and the model then results in 0 degrees of freedom and a model fit test that is 0. So for example, a chi-square test could be performed on a path model like that, or a structural equation model, and then in this case the test would not be relevant because it would have 0 degrees of freedom and the test statistic would be 0. And so then many people wonder, is that a sign that my model is not interpretable or invalid when it is saturated and I get no test statistic, no meaningful fit statistics, and so on? Another example would be when you have a factor model and you have one factor and three indicators and nothing else. Then one factor model with three indicators and different loadings between the indicators would also be a saturated model with 0 degrees of freedom. And then the question again is, could we use such a model? Would it make sense to use such a model, or is it not valid? Is it not correct to use saturated models? And that is something that confuses many people. When they encounter a saturated model, they think, oh, that is something that I can't use and I can't interpret the results of this model because I have no test statistic and no degrees of freedom for this model. So here in this video, I want to point out that saturated models are actually perfectly fine, and we use saturated models all the time in statistics, oftentimes without being specifically aware that we are using a saturated model. One example is multiple regression analysis or linear regression, which we can perform in standard software such as SPSS. And so whenever we run a multiple regression analysis, then that's a saturated model. It uses all the information that we have from the dependent variable and the independent variables to estimate regression coefficients. And so that model would always be saturated, and we don't care. We still interpret our F statistic for the R squared or multiple correlation R. We interpret the beta or B coefficients, the regression coefficients, and their significance, and we don't care that the model is saturated. And that same logic also applies to path models, factor models, and structural equation models. Even when such a model is saturated, we can still interpret the parameter estimates, and we can still get something useful from such a model, provided that there are no other problems with the model. So of course the model should be plausible and should contain only proper estimates and no other estimation problems. So for example, not abnormally high standard errors or something like that, or negative residual variance. But if that's the case, that we have all proper estimates, then we can definitely interpret those. For example, in the mediation model, in the simple mediation model that I mentioned at the beginning, where you have x, m, and y, and you estimate all three paths, a, b, and c prime, that's perfectly fine. It gives you the a, b, and c prime paths. It also gives you r squared for the mediator. It gives you r squared for the dependent variable y. It gives you the indirect effect a times b, and you can do a test of significance for the a times b indirect path, or the a times b product of paths. And so that might be all you want. Maybe that's all you need, is a test of mediation, a test of whether c prime is significant or not, a test of whether the product a times b is significant or not. And you can do that, and you can compute p-values, or you can compute confidence intervals, and that's all possible for a saturated model. And it's perfectly fine to do that even without degrees of freedom. So say for the model fit test, a saturated model by definition always fits perfectly, because it, so to say, exhausts the data. It uses up all the data that are there. It doesn't simplify your data, so to say. It just uses up all the pieces of information that you have and transforms them into free parameters. But those parameters might still be useful, because they might tell you something that the observed data directly does not tell you, meaning the observed covariances and variances and means, they might not directly show you what you want to know. And so then estimating a saturated model that transforms these pieces of information into more useful parameters might still be worthwhile. In the case of a mediation model, for example, the observed covariances, variances, and means would be transformed into those a and b and c prime paths. That might be useful. Likewise, when you estimate a saturated factor model, such as a single factor model with 3 indicators and different loadings, a so-called congeneric measurement model, that might be useful even though it is saturated, even though you cannot test whether truly those 3 indicators are congeneric, are unidimensional. You can still get parameter estimates that are useful. For example, you can get the standardized factor loadings from such a model. You can get the r squared values for the indicators, which can be interpreted as reliability estimates for the indicators under the assumption of congeneric measurement. And then also you could compute a composite reliability coefficient based on the standardized loadings, such as, for example, McDonald's omega. And so that might be useful enough. That might be what you want to know. You might want to know, are those 3 indicators reliable indicators of this factor? And then that's what you get, so to say, even though the model is saturated. So I hope you saw through this video that saturated models can be totally worthwhile, can be totally useful, and are not invalid necessarily, and are not something that you need to avoid. One drawback, of course, is that those models are not testable. They cannot be tested against the observed data, because they will always trivially fit perfectly. There might be other signs, so to say, that might show you that the model doesn't fit. Like, for example, when you have negative covariances, then a single factor model wouldn't make sense, where you would assume that all the covariances are positive, or if you can see that one of the correlations or between your indicators is very small or more, then also this would, so to say, indicate that a single factor model is not valid even when it's saturated. Or if you get an improper solution, such as a negative variance, a negative residual variance estimate, that could still falsify the model. But what you don't get is an overall test of model fit for a saturated model. So that's a downside, but other than that, saturated models can be fine, can be useful, and there's nothing, so to say, that tells us that they should be totally avoided. I hope you found this video useful. If you did, please subscribe to this channel and hit the like button. Don't forget to check out the description for additional resources, and I'll see you next time.